Populations, samples, and hypotheses. All right, here's the state standard that goes with this lesson. To be successful, you need to be able to distinguish between populations and samples. You need to be able to find a sample proportion. You need to be able to use a simulation to test a hypothesis. New vocabulary. Population is the collection of all data, such as responses, measurements, or counts that are of interest. A sample is a subset of the population. A parameter is a numerical description of a population characteristic. Statistic is a numerical description of a sample characteristic. And a hypothesis is a claim about a characteristic of a population. For example, a medical researcher claims that the proportion of U.S. adults living with one or more chronic conditions, such as high blood pressure, is about 0.45, which is 45%. Example 1, distinguishing between populations and samples. Identify the population and the sample. Describe the sample. So A part says, in the United States, a survey of 2,184 adults ages 18 and over found that 1,328 of them own at least one pet. All right, so the question says, identify the population and the sample. So we're talking about people in the United States, and this says that people who are adults 18 and over. So our population is going to be all adults ages 18 and over in the United States. All right, so we've recognized that the population represents all the adults ages 18 and over in the United States. So what does that mean that the sample is going to describe? So the sample would consist of the respondents that they surveyed. So the 2,184 adults would be the sample. All right, and we can represent this in a diagram. And the diagram kind of shows the whole population with the subset of the sample taken. So let me see if I can get that. All right, so here's the image from your textbook. So the whole population, all the adults not in the survey, would be outside the sample. And then this represents, this portion in the middle here, represents the sample of the respondents of the adults in the survey. So that means that there's 1,328 adults who said they own a pet, which you can conclude that 856 adults who were surveyed did not own a pet. All right, let's look at B part the same way. So B part says to estimate the gas mileage of new cars sold in the United States, a customer advocacy group tests 845 new cars and finds they have an average gas mileage of 25.1 miles per gallon. So the entire population would be what? To estimate the gas mileage of new cars sold in the United States. So the population would be all new cars that were sold in the United States. All right, so we'll answer B part over here on the right. So if we know what the entire population is, now we have to describe the sample. All right, so the sample consists of gas mileage for the vehicles. Let's see, it estimates gas mileage of the 845 new cars tested by the group. All right, so the sample consists of gas mileage of the 845 new cars that were tested. All right, so we can make a diagram again that has a sample with a subset that has gas mileage of new cars in the United States. And the sample consists of the 845 new cars with an average of 25.1 miles per gallon. So let's see what that looks like. So it's going to look very similar to part A. So all of this area out here represents gas mileage of new cars that were not in the test. And then you have this sample space The sample consists of the 845 new cars that were in the test. And remember, together, the cars not in the test and the cars that were in the sample, they make up the entire population, just like it did over for Part A. So the most important thing here is to recognize the difference between the entire population that they're talking about, whatever the problem is asking, and then can you determine the sample space that is separate from the entire population. Example 2, distinguishing between parameters and statistics. A part, for all students taking the SAT in a recent year, the mean mathematics score was 531. Is the mean score a parameter or a statistic? Explain your reasoning. All right, so let's think about our definitions again. That's always going to be helpful. So a numerical description of a population characteristics is called a parameter. So a population, remember, is the whole, everything. That's called a parameter. So a numerical description of a sample characteristic is called a statistic. So because some populations are too large to measure, a statistic such as a sample mean is used to estimate the parameter, such as the population mean. So it's very important to be able to distinguish between a parameter and statistic. So based on those definitions, a numerical description of a population characteristic is called a parameter. I can say because for all students taking the SAT, this says all students, then we can determine that this one is in fact a parameter. Okay, so it wasn't a sample, it was based on all. So because the mean score of 531 is based on all the students, we know that that is in fact a parameter. All right, B part. A survey of 1,060 women ages 20 to 29 in the United States found that the standard deviation of their heights is about 2.6 inches. Is the standard deviation of the heights a parameter or a statistic? Explain your reasoning. All right, so this is a survey of 1,060 women ages 20 to 29 in the United States. So anybody with any kind of logic knows that there's a whole lot more than 1,060 women between those ages in the United States. So we can quickly determine that that is a statistic. So let me write this out. All right, so this is kind of the short version. It is a statistic because there are more than 1,060 women ages 20 to 29 in the United States. All right, so do note, though, that if a sample is representative of the population, then you can estimate that the standard deviation of heights for all women ages 20 to 29 is about 2.6 inches. But again, you have to make sure that the survey was unbiased and it represents the entire population in order to do that.